Okay. So on the first day of notes, we just discussed what a power was, what exponent, and how they worked. From this point on, we're going to learn how to do some arithmetic with exponents, with powers. So in today's lesson, we're going to be looking at, hey, what if you have more than one power and you want to multiply them? What do you do to make a single power? Or what if you wanted to divide two powers? What do we do? All right? So this point on, we're just looking at the rules to combine powers together. Okay? Now, I'll tell you right off the bat, this is an important thing. Yes, Alana?
Do you have to do that with the bedmass rules? So the brackets and
We will build up to that. All right? So today, we're just looking at multiplying and dividing. Now, I'll tell you right off the bat, these rules only work if the bases are exactly the same. Like a 3 and a 3 and a 5 and a 5, right? If they're not the same, you can't apply these rules, right? In grade 9, we mainly work with numbers, right? In a couple chapters from now, we'll do a couple letters. In grade 10, you basically repeat this whole entire chapter, but the whole thing is you using variables, letters here. All right. So let's look at multiplying first, right? Last day, if we had an exponent like this, we said that meant that the 3 gets repeated 7 times. So we write that out 4, 5, 6, 7 times. All right? And if we had this, that meant that 3 gets repeated 2 times. Yes, Sam?
Do we copy exactly what you do?
Yeah. This is part of your notes. Right? 3, 3. Right? They say one of the best ways to study is actually writing. The process of writing helps ingrain ideas in your brain. So what we want to do is we want to multiply these together. So we still have this multiplication that we need to do here. So if I wanted to write this expression as a power, what would you say the base is? What would you say the exponent is? Anybody? What's the base? Phoenix? The base is not 6. Base is what gets repeated. What do you see being repeated? 3. Right? So the base is 3. And the exponent is how many times it gets repeated. How many times does it get repeated there? We have to count all these up, right? Is it Goshen?
Yeah.
Yep. 9. So if you counted these up, well, there's 7 here, so that's 8 and 9, right? A very tedious and not so fun way of doing this. Can somebody look at the original question here and figure out what the rule must be to determine what the exponent is? So look at this, and look at this. How can we do a shortcut to go from here to there? What do we do? Alana?
So I'm guessing you times the 3 and the 3, and then you times the exponent and the exponent. Or no, you just times the exponent.
If you times the two exponents, you get 7 times 2, which is 14.
It's already going to be 3. You just need to figure out the exponent.
Yeah. So if you multiply those, you get 14. But we wanted 9. So that doesn't work. What else could we do? Max?
Add the 2 exponents.
Add the 2 exponents. Right? We have 7 of these. We have 2 of these. Altogether, we have 9. 7 plus 2 is 9. Right? That's basically what we did. We drew up 7 of these. We drew up 2 of these. Altogether, we had 9 of these. So we add the 2 numbers together. So the rule is, if we are multiplying, we add exponents. Only if the bases are the same. All right? Because we're grouping the 3's together.
And it doesn't work at all if they're different?
Yeah. Because then, if this was like, say, a 7 here, we couldn't say that a single base, because it's not the single base being repeated, right? Okay, So let's quickly go to this side. We're going to do the left-hand column. Then I'll get you quickly to do the right-hand column. So I'm going to just yell out to you guys. I want you guys to volunteer answers and ask for what's the base, what's the exponent. First question. What's the base here for a single power? Alana,
2.
what should the exponent be?
That would be 3 and 4.
3 and 4, what does that make?
That makes
7, right? We're adding those together, right? The base stays the same. The exponent we add. Next question. What's the base? What's the exponent? Phoenix.
-4 in the brackets.
Yeah. Remember to include that -4 in brackets. Phoenix, what's the exponent?
4.
4. 2 plus 2 is 4. Okay. Third question. What's the base? What's the exponent? Alana?
6 and 2.
6 and 2. Do you guys agree? Sort of makes sense, right?
So
But
that one, if it's
this one is incorrect. Okay? Max?
It's 6 and 3.
It should be 6 and 3. And I'll explain that right now. Right? Let's go back to the way what this means. This means we have 2 6s multiplying each other. And we still have this other 6. How many 6s do you have altogether?
3.
3. So, in math, if there is no exponent, it means there's an imaginary 1 there. It's not a 0, it's a 1. Right? So you have to go 2 plus 1, which gives you the 3. Right? So maybe make a little note if you need to help remind yourself. Right? Right? If no exponent, it means exponent is 1 or something, whatever you want to help that stick in your brain, right? Because a 0 is a special exponent, and we'll talk about that in your next class or in a following class coming up here. Okay, third question. What's the base? What's the exponent? Mikey?
9 and 3 or 6.
Yep. The base doesn't change. The exponents we add. All right. Last one. What's the base? What's the exponent? Alana?
It doesn't work.
It doesn't work. Right? The bases are different. It doesn't work. So we can't combine this to make a single power. So we write down not possible. So if I give you a question like this on a test, don't write down blank, right? Because that doesn't tell me if you understand it or you just didn't know what to do.
Will there be one like that on the
I don't know. It's not beyond me to do it. I showed you in the notes, right? So the right-hand column is asking you to evaluate. So even like on this last question, you can't combine it to make a single power, but we can still evaluate this. This does equal a number. So I'll give you guys like a 10-second head start. Just practice your calculator work. And then I'll write out the answers here. See if you can use the exponent button and you come up with the right answer. Then I'll just write and just look up and see if you got it right. All right? So I'm hoping at this point it's pretty straightforward. And if you're making calculator errors, come see me today. We'll be doing a quiz next class. I don't want you losing marks because you don't know how to use a
I
calculator.
thought it was today.
It was originally supposed to be today, right? But we're a little bit behind schedule because of what happened last time. Other classes will be doing it today.
We have a quiz on Monday.
Monday. We'll do a little bit of review beforehand, so don't worry about that. Like I said, my quizzes aren't very big. You asked people who had me last year, the grade 8s last year, or the grade 9s if you know any. They're not very big. Okay, I'll just throw in another question here. What if I had something like that, and I had 3 terms?
Then it doesn't really matter, right?
What would we do? What would the base be and what would the exponent be? Sam?
Well, I know everything would be pretty much similar to. I'm guessing.
Yeah, you're on the right track.
Everything would be similar. It just the top 3, the 5, 3, 4. You add all those.
You add all those together, right? So the base doesn't change. They're all the same.
So it's
And we add the tops. 5, 3, and 4. So 5 plus 3 is 8. 8 plus 4, 12, right? And that's what it would be. Right? Just think about it. If there's 3 of them, it'd be just like this question here. You should add another multiplication here, and you're just still adding and counting, right? Still the same thing. Awesome. I'm glad that you guys are finding this easy for the most part. Okay? So 4 to the 12, right? It could be 3 terms. It could be 15. As long as the base is the same, all you're doing is adding the exponents, right? Okay. So that's multiplying. Multiplying, we add. So with dividing, we have another rule, and these rules are actually called laws. These are exponent laws. Once again, they only work as long as you have the same base, right? Now, the explanation for the dividing rule may come easy to you depending on how your grade 8 teacher showed you how to simplify fractions. So this statement here, if you want to divide it, remember dividing just means, these two mean the exact same thing, right? A divide line could be just, this is the numerator, this is the denominator, right? Right? So,
I remember doing this in grade 7.
yeah, good. Right? Now, 3 with an exponent 7 means that 3 gets repeated 7 times. So we go 1, 2, 3, 4, 5, 6, 7. And a 3 with exponent 5 means that 3 gets repeated 5 times. 2, 3, 4, 5. Give me a second to write that out. Okay. Yes, Max.
The second power, the second power is only 3 to the power 2.
Oh, sorry. I made a copying down mistake. Sorry. Thanks for catching that, Max. The question said 3 to 2. So that should be, thank you, Max, 3 times 3. Okay. Sorry. Thank you. Okay. Makes it a lot faster to write this out. Now, with simplifying fractions, you can cancel numbers from the top to the bottom out as long as they're the same. As long as the factor is the same. If we have 3 on the top, that can cancel a 3 on the bottom. Right? And we have another 3 on the top, that can cancel another 3 on the bottom. So that's how simplifying fractions go. Last year, your teacher may have done factors like if you have 6 on the top and 6 on the bottom, they can cancel out. Right? I know I did it with my students. Depends on the teacher, what technique they teach. Right? So now you go, okay, all the bottom's gone. The tops 2 are gone. We're left with just 5 3s left on the top. So this is what we're left with. 4, 5. So if you wanted to write that as an as a power, that the base is 3, the exponent is 5. Maybe we have 5 3s left. Now, instead of having to, once again, write out the repeated multiplication and do all this work, can you look at the original expression and say, hey, can I think of a math rule to figure out how to go straight from here to there? The base doesn't change, but Alana, oh, actually, I'll ask Marika. You minus them, all right? So you have 7 and a 2. We subtract them. So that gives us a 5. So the rule is, if we're dividing, we subtract. Right? So that's something that you do need to subtract. You need to memorize. Right? Multiplying, we add. Dividing, we subtract. Right? And now what I sort of maybe helps the students out, I'm not sure if it really works or not, depends on the student. Like, if you look at the division symbol, it sort of looks like a minus sign with the extra dots, right, to help you sort of remember, right? So with division, we're going to subtract the exponents if that helps you remember it. And the multiplication symbol is like sort of a addition symbol turned, rotated slightly, if that helps. Okay? So let's do this one over here. Okay? Same as the ones above. What's the base? What's the exponent? All right? First question. What's the base? What's the exponent? Here we go. Alana? Okay. 3 is the base. What's the exponent?
2.
Thank you, Sam. All right? And we can only do these if their bases are exactly the same. Next one. Are the bases the same? They look the same to me. All right? Yes, Max?
-3 in brackets.
-3 in brackets.
3.
And 10 minus 7 gives us 3. That's where the 3 comes from. All right. Last one. What's the base? What's the exponent? Phoenix.
The base is 8 and the exponent is 1.
The exponent is 1, you say?
Yeah.
Is 2 minus 2 1?
No, but I probably couldn't use 0 as an exponent.
You can use 0. Yes, thank you. Yeah, so you can use 0 as exponent. All right? Because 1 is different than 0. All right? Okay. Now, evaluate. All right? Give you a couple seconds head start. See if you come up with the right answer. Did the 8 one look a little weird? The last one, the answer?
Yeah.
Yeah.
I was
Yeah.
confused for a second, but I got it.
Yeah. So you should have came up with 1 when you punched it through your calculator. And in fact, we're going to talk about 0 exponent in a follow-up lesson. Anything with exponent 0 is always equal to 1.
Okay.
All right?
That makes things easier.
Yeah. Right? Because it's like, remember, this tells you how many times do we repeat this. We don't repeat it. All right? All right. And if that doesn't make sense to you, you can think of this. 8 over 2, or 8 over 2, just like that. That is same thing as saying 64 over 64. Top number divided by bottom number is always exactly the same. That always equals 1. Right? Whatever helps. That's thinking and memory. I'm just introducing it now. All right? And be careful on this one. Don't say blank. Don't say blank there, because remember up above, blank means 1. So we do need to include that 0 there.
So you get marks off if you don't get the 0?
Yeah, it'll be incorrect, right? Because the difference between 8 to exponent 0 means it's equal to 1. 8 with a blank there means the value is 8, right? Two different numbers. Right. Okay. Last question. Okay. So in this question, we have multiple operations going on. We have a multiplication and a division, right? And here they say Rico was asked to solve this question and make it into a single power, or evaluate it. And this is the work he showed. And then asking, did he make a mistake or is his answer right? So we work our way through this, okay? If you're given a question like this, our first step is to just clean up the numerator or the denominator, then compare the top to the bottom. So that's what he did here. We look at this. If you combine these two together, is the correct process adding 6 and 3 together to make 9? Is that the right thing to do?
Yes.
Yeah. So this step looks good, right? And we agree with the 9 up here. Okay? Let's look our way down. Okay, going from here to here, looks like he said, okay, the numerator stays the same, but the denominator turns into a 3. Does that look okay to you? What do you see? What don't you like about it, Sam?
I don't really know.
Right? It just doesn't look right? Jack, do you think you know?
I don't remember what the small number is called, but should the 3 have a small number on top of it?
We lost an exponent, right? So either he lost an exponent, or is 9 cubed equal to 3? If you did that on our calculator, does that equal that? Let's see. I doubt it. It doesn't make sense to me. Right? So there's definitely 729. So there's definitely an error here. So the question is, what should he have done? Right? So if we have this question at this step, and that was right, right? And I'm going to rewrite this instead of a fraction into a division statement like this. We just did this on the back page. What do we do here? Like we talked about bases and exponents. What should the next step base be and the next step exponent be? Sam?
Actually, I'm sorry.
James? No, sorry, Mikey.
Minus the 9 and the 3.
Minus the 9 and the 3, that gives us 6. So do I write down a 6? That's the exponent, right? So this would be equal to 9 with an exponent 6. We subtract those two, right? That's the rule. When we're dividing, we subtract the exponents. So the division statement could look like this, or it could look like a fraction. They mean the same thing. Right? Now, once that we have this as a single power, it's easier to evaluate. And you come up with the right answer. So you grab your calculator, you go 9 to the exponent 3. 9 to the exponent, 6 is 531,441. 531,441. Right? That's what the correct answer should be. Straightforward?